Hi friends, so let us do a few more problems wherein we factorize by inspection and then find the roots of the quadratic equation. Okay, so assume that we are given 3x squared plus 5x minus 2. Now you have to find two numbers whose product is equal to a into c. What is a here? It is 3. What is c here? Minus 2. So find two numbers whose product is 2 into minus 2 into 3, that is minus 6, and whose sum should come as 5. Okay, so if you take minus 6, you can express it as 6 into 1, minus 2 into plus 3, 6 into minus 1, etc, etc. Correct? But only 6 and minus 1, this combination gives you the right answer because you need a 5 here. So if you take 6 and minus 1, when you multiply both, you will get minus 6. When you add both, you will get plus 5. So this combination is good. So 3x squared plus 6x minus x minus 2, we can split the 5 as 6x minus x. Then from 3x squared 6x, you can take out 3x common. Okay, that leaves it with x plus 2. And here you can take minus 1 common, that gives you x plus 2. So if you take x plus 2 common, you will be left with 3x minus 1 and x plus 2. Okay, to find the roots, you equate it to 0. So 3x minus 1 into x plus 2 equal to 0. So either 3x minus 1 is 0 or x plus 2 is equal to 0. So if 3x minus 1 is 0, 1 can be sent this side of the equal to sign, it will become positive 1. The 3 can be sent to denominator, so x will become 1 by 3, or you can send 2 to the other side of the equal to sign, you will get x is equal to minus 2. Okay, so the roots are x is equal to 1 by 3 or x is equal to minus 2. Now to verify, you just substitute in the equation. So p of 1 by 3 is, instead of x, I have put 1 by 3 here. So into 3, 1 by 3 whole squared plus 5 into x, that is 5 into 1 by 3 minus 2. So 1 by 3 whole squared is 1 by 3 into 1 by 3. Right, I have written this down here. There is a 3 here which will get cancelled. Your remaining thing is 1 by 3 here. Here you get 5 by 3 minus 2. So 3 is the same denominator. So 5 plus 1, you'll get 6 by 3, which is actually 2 because 3 2s are 6. So 2 minus 2, you'll get 0. So that is verified. What about minus 2? P of minus 2 is 3 of minus 2 whole squared, 5 into minus 2 minus 2. So minus 2 whole squared, you'll get 4. 3 4s are 12. 12 minus 2, 10. And again minus 10 here, you'll get 0. Okay, so like this, again you have done the inspection, you have factorized it, you have equated it to 0, and you have found the roots. Okay, let's take the next example. X squared plus 7x plus 10. Okay, again find two numbers whose product is 1 here and 10 here, 1 into 10, 10, and whose sum is 7. So 10 can be expressed as 1 into 10 or 5 into 2, but you need to take the 5 into 2 combination, because 5 and 2, when you add it up, you'll get 7. Okay, so once you get this combination right, you split the center factor as the combination. So you can split it as x squared plus 5x plus 2x plus 10. And here you can take x common out, you'll get x plus 5. And here you can take 2 common out, you'll get x plus 5. Then x plus 5 into x plus 2 is what you can get. Okay, those are the factors. To find the roots, just equate it to 0. X plus 5 into x plus 2 equal to 0, which means x plus 5 equal to 0 or x plus 2 equal to 0, or when you send it to the other side of the equal to sign, x is equal to minus 5 or x is equal to minus 2. To verify, you can put substitute the value in this equation. So p of minus 5 is minus 5 squared plus 7 into minus 5 plus 10. Okay, so minus 5 squared is 25, 7 5s are 35, minus sign is there, minus 35 plus 10. So 25 minus 35 minus 10 plus 10, you'll get 0. Okay, to verify p of minus 2, you can substitute minus 2 squared there. So minus 2 squared plus 7 into minus 2 plus 10. So minus 2 into minus 2, you'll get 4 here. 7 2s are 14 minus plus 10. So 4 plus 10, 14 minus 14, you'll get 0. Okay, so the next example, x squared minus 3. This looks like a squared minus b squared, right? Where a is equal to x and b is equal to root 3. So a squared minus b squared, as we know, is a plus b into a minus b. So we can write this as x plus root 3 into x minus root 3. So you can factorize not by inspection this time, but by using a standard formula. Okay, to find the roots, equate x plus root 3 into x minus root 3 equal to 0. X plus root 3 is equal to 0 or x minus root 3 equal to 0. So x is equal to minus of root 3 or x is equal to plus root 3. Okay, so to verify, you substitute p of minus root 3 squared minus 3 minus root 3 into minus 3, you will get 3 minus 3 equal to 0. If you substitute root 3 also, root 3 to root 3 is 3 minus 3, you will get 0. So x is equal to minus root 3 and x is equal to root 3 are the roots. Okay, now you have solved it using inspection. Now can we solve the same problems using formula? Give the quadratic formula to solve the above problems. Okay, same problems: 2x squared minus 8x plus 6, which you have seen before, 3x squared plus 5x minus 2, x squared plus 7x plus 10, x squared minus 3, and we have given you two more problems here, x squared and x squared plus 1. Okay, now the generic formula for solving equations of the type ax squared plus bx plus c equal to 0 to find the roots, the procedure is below. Okay, first you have to calculate capital D is equal to b squared minus 4ac. Okay, this is what is known as the determinant. Okay, now if the D happens to be less than 0, this quadratic equation will have no roots. If the D equal to 0, then the quadratic equation will have only one root, which is minus b by 2a. If the D is greater than 0, then the quadratic equation will have two roots. One root will be minus b plus square root of D divided by 2a, and the other root will be minus b minus square root of D divided by 2a. So this is the formula for solving the quadratic equations. Okay, let us try it out. Let us try it out on this equation, the expression 2x squared minus 8x plus 6. Here you can see that a is 2, correct? B is minus 8, correct? And c is 6. Now let us calculate the determinant first. What is determinant? B squared minus 4ac. What is b? Minus 8. So substituting minus 8 whole squared minus 4 into a, that is 2, into c, which is 6, right? So minus 8 into minus 8 is 64. 4 2s are 8, 8 6s are 48. So 8 6s are 48 minus 48. So what remains is 16. Okay, now 16 is greater than 0. So D is greater than 0. So here we will have two roots for this equation. What are the roots? First root is minus b, okay, minus of b. So b is minus 8 minus of b plus root of d, square root of d, as we have shown here. What is square root of d? It is square root of 16, so 4, divided by 2a. What is a? It is 2, so 2 into 2, that is one root, or minus b, okay, minus square root of d divided by 2a. So here you will get minus and minus, here you will get 8 plus 4, 12, 12 by 4, or here you will get 8 minus 4 by 4. So x is either 12 by 4, which is 3, or x is equal to 8 minus 4, which is 4 by 4, which is 1. So the two roots are 3 and 1. Okay, to verify, just substitute back. P of 3 is 2 of 3 squared minus 8 into 3 plus 6. Now 3 3s are 9, 2s are 18. 18 minus 24 plus 6. Okay, 18 plus 6 is 24, minus 24, you will get a 0. Similarly, P of 1 is, you substitute 1 in this equation. So when I substitute 1 for x, 2 into 1 squared plus 8 minus 8 into 1 plus 6. So 2 plus 6 is 8, 8 minus 8 is 0. So this is verified. Okay, so this is how we have used the formula, this formula. Okay, we have used this formula to find the root of the equation. First you must find the d, b squared minus 4ac, and then depending on whether d is less than 0, it will have no roots. D is equal to 0, it will have one root, which is minus b by 2a. And if it has two roots, that will be minus b plus root d divided by 2a and minus b minus root d divided by 2a. So please remember this formula. Okay, let's try it out on another example. 3x squared plus 5x minus 2. Here a is equal to 3, you can see, b is equal to 5 and c is equal to minus 2. So what is the determinant? Determinant is b squared minus 4ac. What is b? It is 5 squared minus 4 into a into c is minus 2, so I have substituted minus 2. Okay, so this is 25 and minus sign will give you a positive sign. 4 3s are 12, 2s are 24, 25 plus 24, 49. D is greater than 0, then therefore we'll have two roots. So what are the roots? Minus b, okay, minus b plus square root of d. What is square root of d? Square root of 49, which is 7. Okay, minus b plus square root of d divided by 2a. What is a? 3. So 2 3s are 6. Or minus b minus square root of d divided by 2a. So here you can see that 7 minus 5 you'll get 2 and 2 will cancel. You'll be left with 1 by 3. Here what you will get? Minus 5 minus 7, which is minus 12. Minus 12 by 6 is minus 2. So x is equal to 1 by 3 or minus 2. Okay, so to verify, again we take p of 1 by 3, that is 3 into 1 by 3 whole squared, 5 into 1 by 3 minus 2. So 3 into 1 by 3 into 1 by 3, 3 cancels, 1 by 3 remains, here 5 by 3 remains, right? 5, this and this 6 by 3, you'll get 2, 2 minus 2, you'll get 0. Similarly, p of minus 2, here you'll get 3 4s are 12, 12 minus 2, 10, and 5 into 2 minus sign is there, minus 10, you'll get 0. Okay, so again we have used the formula this time. Previously we used inspection, here we have used the formula. Okay, now one more example, x squared plus 7x plus 10. Okay, and you can see that a is 1, b is 7 and c is 10. What is d is equal to b squared minus 4ac? Determinant, it is 7 squared b squared, that is 7 squared minus 4 into 1 into 10, that is 49 minus 40, which is 9. Again d is greater than 0, so you'll have two roots. What are the roots? Minus b, okay, minus 7 plus square root of d. What is square root of d? Square root of 9, which is 3. So minus 7 plus 3 divided by 2, or minus 7 minus 3 divided by 2. So here you will get minus 4 by 2, that is minus 2. Here you will get minus 10 by 2, which is minus 5. So x is equal to minus 2 or minus 5. To verify, you just substitute in the equation. So minus 2 squared plus 7 into minus 2 plus 10. So minus 2 into minus 2, 4. 4 plus 10, 14. And here you will get 7 2s are minus 14. So 4, 10 minus 14, you will get 0. Okay. Similarly, minus 5 squared into 7 into minus 5 plus 10, right? Minus 5 into minus 5, 25. 25 plus 10, 35. And here 7 5s are 35, minus sign is there. So 35 minus 35 is 0. Okay, so friends, again we have solved another problem using the formula. Okay.